The next presenter, now we are going into the afternoon session, and Mr. Owila to present on irrigation water application systems and productivity trials report.
Good afternoon. I know that it's a bit taxing presenting after lunch, so please bear with me. I'll try to be as brief as possible without compromising the quality of the presentation, and I seek your utmost attention. Ours was to evaluate the productivity and water use efficiency using different irrigation methods. As a background, we appreciate the fact that Kenya is an agricultural country that is predominantly rain-fed, and the productivity of that kind of production has been declining over time. And the fact that the economy is very sensitive to agriculture, such that if there's a 1% change in agriculture, either positive or negative, it automatically follows that the economy suffers by 1.6%. Irrigation has been shown about its potential elsewhere in the world. In Asia, they are achieving as much as 100% in terms of yield increase. So we in Kenya are under pressure, therefore, to increase agricultural productivity through irrigation. But we must appreciate that since irrigation is expanding more so in the so-called ASAL areas, it's a very fragile environment where water is very scarce. We must also appreciate that the other non-agricultural sectors also demand that water. And for us to equitably distribute that water amongst all these economic sectors, there is need for water use efficiency and water productivity in whatever sector, whether industrial, municipal, or agricultural. We have a system that we've been using mainly flood and furrow in Kenya predominantly, but we are aware that there are other more superior technologies like sprinkler and drip. However, what informs the decision on which technology or method to use in which scheme? There need to be local trials. So our objective for determining the water use efficiency of those methods and the water productivity of those methods using a few crops that are common: rice, maize, green grams, common beans, oilcose beans, cowpeas, and soybeans. And these trials were carried out in Mwea, Perkera, and Bura. The methods were drip, furrow, and sprinkler, and the plotting was done and the volume measure of water measured as described, and standard agronomic practices were also carried out as recommended for the respective crops. The treatment was irrigation system on the various crops. It was 3 systems, and the data was collected on the soil, physical or chemical parameters, meteorological data, the volume of water, plant density, crop vigor measured in terms of plant height at 14 days intervals, and the time taken by the crop to reach 50% flowering and 50% maturity, and then days to harvesting, and finally the yields. Since this trial is in its final stages, we are now harvesting. There was a delay in the first trial which was interfered with or got spoiled by the rain. So the repeat trials are doing well, but now we are now harvesting. But we have the data that I'm going to present here will be based on the growth parameters as we have seen them. And because of time, I'll present the data from where, and there was no significant difference in the irrigation system effect on the crops in terms of, for beans and oilcose beans. You can see the graphs, the one to your left-hand side, the one for common beans, and the one on the right-hand side is the one for oilcose. But still, something is apparent there. The behavior of the respective crops to the methods of irrigation. In the green drums, again, we don't see apparent significant difference within the irrigation, but between the irrigation systems, you can see that there's a kind of a trend that drip applied crop seems to be doing better in terms of biomass accumulation and therefore plant height as compared to furrow and sprinkler. And the same trend was more or less apparent in the maize, where we are having again that kind of that the drip is performing better than sprinkler, and the same to soybean. Although, if we look at these graphs, there are some differences, but the crops also behave in a funny way. They don't all respond to the systems equally. Look at the beans, for example. It's more responsive to furrow than sprinkler. So if we have time, we'll go through each one of them. But as much as we're waiting for the final results to be analyzed, provisionally we can see that the irrigation methods affect the crops differently. In other words, different methods are needed for different irrigation. The chairman gave his frustration this morning when he was telling us about the amount of load he has on his head to expand irrigation. One challenge that is immediate is you are expanding the land, but what do you put in that land? Now, these provisional results are showing that we need to do more before we do the expansion. We have the option of expanding the land and then worrying about the crops to put there later. What is the danger there? Is that we may end up with crops that may not be responsive to the technology that we have already established. You have a system that is not already installed, your drip system, and then the kind of crops that you have on the ground may not be appropriate for that. The other option is that if you already have a situation where you have a fixed system in place, then what combination of crops? So then now you need to look into the combination of crops. And especially now that you're talking about intensifying water and land use by having more than one crop in a season, then the need is there, a very, very strong one, for us to be able to carry out even more trials on the array of crops that can be available to the farmers to choose sort of select from. So I rest my case there. Please, I encourage patience.